Hi, now I'll be explaining the fan cart speeding up in a negative direction. Uh, just like the fan cart speeding up in the positive direction, it's an arched line, so that represents a change in speed. Um, so, and since it's arched this way, it's speeding up, and since it's arching downwards, it's speeding up in a negative direction. Um, with this position time graph, we see that its y-intercept. Hold on one second. Um, let me get the linear fit just so I can find the y-intercept. Its y-intercept is 34 inches. So that means from our origin, it was 34 inches. It started 34 inches away, and it moved faster, closer to our origin. Um, with the position time graph, we get its derivative, and just like with the other graph, we get its velocity. Um, it's a little wonky, this velocity graph. I'm not really sure why. It's probably just because our data points are a little screwed up. Um, I also did a did another one with data from another group. This being that group, it's the data's, as you can see, it's a lot cleaner. But I'm gonna stick to mine with explaining it. I'll go back to this one to show a little cleaner point. But with my groups, I managed to find the slope of this velocity graph. Oh, and by the way, since the velocity graph is more or less a, a lot more less a straight line like the other one and going downwards, so it'd be a negative slope. It's going in negative direction. So more or less, I was able to find the slope of this graph, and the slope being roughly 6 inches per second per second. So that means that every second the fan cart's sped up by 6 inches per second. And the reason the slope being a negative is negative direction. The y-intercept of this graph represents its initial velocity, which was roughly 1 inch per second. Um, and with these two numbers known, we're able to find the equation of this velocity graph. And the equation being velocity is equal to negative 6.335 inches per second squared, so inches per second, times t plus the y-intercept, roughly negative 1 inches per second. 1 inch per second being its initial velocity. Going back to the slope, which would be roughly negative 6 inches per second, what it should have been represented by the acceleration graph, the derivative of the velocity graph, which would be the acceleration graph, it should have been represented as a straight line all the way through at negative 6.335. I really am not certain why it ended up like this, but it probably is due to the weird data points we got, some of being inconsistent. So probably human error, probably error from logger, error from whatever. So that resulted in that. Um, Comparing it to the other data, here it's much cleaner. It's the velocity graph, it's a much cleaner slope, but probably it's because it's all the data points scrunched up together. It looks like that, and thus the acceleration graph also looks like all wonky too. Um, but back to our data. Um, Estimating the time and the total velocity, I managed to find the displacement of the fan cart, which is the distance the fan cart traveled. So you get its total time, which would be at roughly, if we look here, it'd be roughly, hold on, it'd be roughly, from where we're counting, 2.096 seconds, and we multiply that by negative 12.5 because that is our largest velocity, and multiply those two together and divide that by 1/2 and multiply that by 1/2, sorry, and we'll get negative 13.1 inches. So it in total it traveled 13 inches in the negative direction. So that is its displacement. That's what the area from here, all of this here, is equivalent to negative 13.1, and that means it traveled 13.1 inches in the negative direction within a period of 2.096 seconds. Yeah.